Okay, now I think it's ready. So let's get started today's lecture. We are in the third week. Today's title is 3D visualization of design. Design is a really big term, as you know, and we are in the Department of Interior Architecture Design. So we need to define design, and we need to figure out what are in the design area, and we need to classify hierarchically and theoretically approach to design by using computing technologies. So as kind of another introductory theoretical background course lecture of this class, we would like to focus on visualization. In other words, some geometric shape modeling and rendering, so-called design representation. Okay, design representation, feature-based lecture for today, and some reminders for your rendering or some computing skills. So here I list what to do today. In the lecture hour, we're going to briefly review some your senior students' work you have visited last week. Okay, so you have voted what you loved among series of graduation exhibition works, and I would like to show you and tell you some technical aspects of such actual design works, and then move on to today's topic, 3D visualization of design lecture, and move on to some technical things as well as lab exercises. Okay, so let's get started. The first thing is graduation exhibition, our department. Sorry for Korean, but anyway, that's the official title for each artwork. So here are some names to vote to this artwork. I don't want to talk about some design concept or design development, progress making, and some qualification or something about design itself. Okay, I like to bring your attention something about technical aspects. Okay, what kind of techniques or computing applications applied for making those exhibition work. Okay, the first one, this one, as well as others, as you see, all they are digitally manufactured things. Okay, for example, this one looks like some floor plan visualization. This one is metal plate. Okay, and there is a kind of scratch on top of the surface. So how to make it? Actually, this one generated by laser cut, but laser cut usually penetrating this kind of metal or wood, even paper panels. But by controlling the power intensity of the laser, we can make some scars, okay, scratches, not cutting it out. So this metal plate, as well as some vector-based 2D image given to this machine, and then we can generate this kind of scars, kind of etching like visualization. So this is another technique of laser cut. And next one, also here, as you find out, this one has some laser cutting based approach, as well as one of the famous fabrication tool, 3D printing. Okay, 3D printer is really convenient, easy to use for making this kind of objects. Okay, and also this one has that kind of laser cut. In this project, they used wood panel. Okay, wood panel cut by lasers, so that they can generate this kind of complicated structure. And also this one is kind of award-winning work in our graduation exhibition. As you see in this project, take a look this mesh model surrounding of their subject. This is their subject design in kind of small scale, and surrounding buildings all generated by that one, okay, that machine. Floater cutter, okay. Floater cutter is in charge of cutting papers, okay. The rolling papers can be fed to that machine, and the real blade going to cut that paper so that we can fold them to make this kind of mass object easily, okay? Not just by hand cut. That machine can be supportive for making this kind of object. And also, this is 3D printing based object. Take a look, this kind of bookshelf, table, and even very small size chairs, and this ceiling structure all printed out by using 3D printers we have, okay? The door next to this room, there is device room, and that room, we have two 3D printers. So that kind of printers, very useful for making this kind of small size interior furniture or interior components, okay? How about those walls? This is totally rectangle shape. If you want to print this out by using 3D printers, that's okay, but even it takes longer time and not convenient. This rectangle shape simply easily cut by knives or some other devices. So comparatively, making this kind of structure, 3D printer is not that good, okay? But this kind of object, complicated and curvy, wave, freeform shape things, very, very good examples for printing out by using 3D printers, okay? This one also has that kind of technique applied and very decent model, and laser cut of the very thick wood panel, okay? By using 2D simple vector shape. Also, this kind of text font can be easily cut by laser cutter, okay? By using your 2D based design. So this one also shows you another example of laser cut. Very thick wood panels stacked, but they have different cuts, and stacked object can be composed like this kind of contour object, as well as some small sized buildings, okay? And this is another award-winning work done by those students beyond war, something like that. This translucent plastic panel is looking like wall or windows or some barriers. But behind this barrier or walls, there are some laser cut objects. Anyway, markup model existing and some fonts written on the surface. So this one comparatively effective and very unique. Another one, another award-winning, so laser cut or prefabricated objects used for markup model. And let's take a look at the surface of this wood panel. This wood panel has some brown color and light brown colors. As you may know, this is sort of side effect of laser cut. Laser beam actually really high temperature. Because of thermal effect, they burnt out, okay? That is why the surface or edge of this line is black, but very dark brown color. But close to that cut edge, they are light brown, simply because of thermal effect, okay? Sometimes this is kind of intentional. This kind of wood can be burnt out like this way, and sometimes this is looking like architectural effect or some coloring effect, and so on. Especially the cutting edge, take a look edges. Their dark brown color makes some difference, so visually sometimes very effective. So that's kind of intentional approach to using the kind of plotter cut. Another example, very nicely and carefully elaborated markup model. This one, also used laser cut and some digital fabrication method. So take a look, very detailed. And some LED lights inside for making this building bright inside, okay? Next one shows you some integrated approach to represent design. This one and the booth design and the model design, building interior design, and some aspect of design in different scale, they all integrated by using this one single booth design, okay? Usually booth is totally different from the building model design, interior design, but this one is kind of integrated approach, okay? Like this way. All laser cut effect and some 3D printing or some prefabricated object and so on. This one is another example. The booth design is, this is warehouse concept. So warehouse concept is totally applied for this one thing, some pieces of warehouse products, okay, for making this booth. So another interesting and unique approach for representing their design concepts and so on. So other examples, all they have some laser cut by using some this kind of plastics, PVC or some any different type of material, but anyway they can be fabricated by using digital applications, okay? So here I briefly reviewed some architectural design work done by our department senior students who's aiming to graduation this year. Anyway, graduation exhibition, you will get into that graduation exhibition work based upon your design studio work after next year. Anyway, developing design is totally somewhat different topic, but anyway, from this course or this kind of design computing course, your technical skills should be enhanced by using several different kinds of machines, tools, software, as well as hardware, okay? So in this semester, I planned 1 or 2 weeks of digital fabrication. I'm going to teach you how to use 3D printers, and based upon your 3D Max modeling work, I'm going to vote some selections, and they're going to be printed out in the classroom, in the lab exercise hours, okay, for yours. So based upon such technical training, hopefully your design going to be very effectively represented in the future. Anyway, let's go back to the course material. The theoretical aspect of today's topic, okay? The first question, my question is, what is the essence of design, okay? Simply say, what's the design? That's the question. So how to define design? That's the first question and first thing we need to figure out. But unfortunately, there is no such formal definition about design. Design is very qualitative, not that quantitative, okay? That is why it's not easy to define the term design. But I like to let you know there is one definition like this way, defined by Chuck Eastman, who was my advisor at Georgia Tech. Anyway, he's one of the leading professor in design computing, which means computationally approaching to design. In a nutshell, he's an expert in quantitative thinking and some computational approach to very qualitative and something really hard to explain, okay? Anyway, take a look at the definition of design. Structured arrangement of design units or design elements. This is kind of recursive definition. We need to know what is design units. So here are definitions of design units. Design units are first, second. First one is physical element that forms a design. You know what is this, okay? This is one type of design. Monitor, computers, smartphones, anything else can be seen. Visible objects are the subject of design, okay? Physical element. What is the next one? An element of design that a designer can cognitively deal with. What is the example of this number 2? What's the example of this number 2? What's the example of this number 2, In-kyung? Okay, first design unit is physical thing. Second one is something not probably physical. What is this one? You cannot touch. It's not tangible, not visible. You already know that. Anyone who knows what's the example for this one, number 2? All of you here already know what it is, okay? For example, design concept, okay? Design concept is abstraction, something invisible, something non-physical. But anyway, there is a concept, okay? What if your design have a physical element only, without any concept or any cognitive things? That is just production. That is the thing that is just existing, okay? Something like stones over there, okay? But if you have an element of design that a designer can cognitively deal with, you can cognitively deal with is design concept. For example, your design concept is red and your objects are all in red. Even if the design is not that good or not, or bad, anyway, the design concept, red color, the image of red, anyway, applied for physical design, okay? That is design, but it's not the end. That is design units. They should be structured, arranged, okay? Structured arrangement. For example, your floor material design, table design, chair design, and wall surface, wall finish design, or color plan, and some other objects, or even ceiling and lighting plans, the combination, their structured arrangement is going to be your interior design, okay? Including all the subjects, as well as untouchable, invisible design concepts. That is design, okay? And usually design is kind of recursive, okay? Sometimes never ending, okay? So your design process going to be create something from your concept again and again to elaborate its design. So designing means process, okay? So this is kind of formal definition. Just one of the definitions that I want to show you. So what we need to do now in the classroom by using especially 3D Max design software, you can realize your design form in computational model. Chairs, floors, walls, windows, and their structured arrangement going to be your interior design, your architectural design, based upon your concept, okay? But actually, I'm not talking about concept or design development, something else. Our focus is how to realize inside of the computer for your physical elements and their arrangements, okay? That's what we're gonna do in this class. So this is really, really simplified process of design, okay? Your design ideas. Design idea is another thing, another example of this one, okay? Second one. Design idea, similar to design concept, is invisible. It's not tangible. So that is in your brain. No one can see it. But it can be seen to others when you create computational model, okay? This class is design computing course. So you can draw by hand, or you can orally express what it is, or you can put your note by using PowerPoint. such kind of things are not computational model directly. So if you create 3D Max model, SketchUp model, AutoCAD, Rhino model, what it is, that is now kind of visible, represented. And this one can be presented by using some sub-visualizations, plan drawings, design slide, renderings, video, animation, whatever, for expressing your ideas by using this computational model. This is the process of designing, okay, by using computer tools. So this is really simplified process of design. What's next? What's next? You know what's next. That kind of design is supposed to be realized in real world, okay? Our industry, building industry, so-called AEC FM industry. AEC FM industry means architecture, engineering, construction, and facility management industry, okay? This industry is kind of really huge sized industry in this planet, okay, on the earth, compared to other industry. What kind of other industry? For example, automobile industry, smartphone industry, Samsung, Apple, cabinet industry, food industry, okay, paper industry, book industry. Amount of industries are there, okay, in our planet, on the earth. But comparatively, AEC/FM industry, building industry, in other words, our industry in architecture domain, right? So our industry is really huge, and amount of people involved in that industry. But the difference between our industry and other industry is very, actually it's very, there are a lot of differences, but one thing that I want to put an emphasis on is this one. They can make one-to-one scale markup model, okay? Think about cell phone, new Galaxy phone, new Apple iPhone. They can make real products before releasing, before selling that products to customers. If they don't like it, just demolish them, okay? And redesign, re-engineering, and re-manufacturing. And then they finalize their product and starting to sell to people. How about building? Your design, if it's realized in real world, but customers don't like it, and they demolish them and try to build a new one, no, that's not going to happen again, never again. Even if your design is not that good, if it's realized, whether it's good or not, it's final product, okay? No retrial, okay? Our product is really big-sized and really expensive. There is no one-to-one scale markup model. That is why design process is really, really critical compared to other industry. For example, Hyundai Motors tried to develop new Sonata. They can make one-to-one scale markup model several times and abandon it until they meet the requirements, their own level bar. But for building industry, there is no test buildings, okay? Only real buildings exist. So because of this difference, huge difference, we have to keep focusing on the design aspect, okay? The importance, the critical thing in design. But actually in this classroom, in this semester, we are focusing on this design side. But that is not enough. Actually, we have to know what's next and some overall some holistic approach to the buildings in terms of its life cycle, okay, building's life cycle. So as you may know, of course, they are supposed to be constructed, erected in actual site, okay? On-site construction for structural elements, on-site construction for interior facilities, okay? And then it's going to be realized as built. But another one, some shop fabrication, prefabrication, rapid prototyping. This kind of objects can be fabricated, manufactured in shop or factories, and then transported to on-site and installed, okay? All those features, as we see today, graduation exhibition work, mock-up model making is one part of this one, okay? Actual construction, but it's not in one-to-one scale, small sized scale. Anyway, within this life cycle, computer tools capability is very critical, okay? Digitally fabricated, digitally prototyped, digitally managed this kind of on-site construction and so on. Even realized building managed by computing technologies, okay? Facility management. Of course, our main subject, design process, done by computers, okay? That's critical aspect of this, of our class in terms of design computing. So, in terms of building life cycle, we need to differentiate some modeling and design approaches for visualization and for such building life cycle, okay? We don't need to consider everything when you are designing in your design studio, okay? At first, our top priority can be design representation or design visualization. We don't need to take care of the actual management of that building at first stage when you are students, okay? That is why this class mainly focusing on this kind of technical aspects of computing tools. But actually that is not true. Even by using computing tools, we can take account building life cycle, building information. That is your next phase topic, okay? Building information modeling, different type of applications. But in this semester, in this course, in CAD&graphics2, anyway, our focus is on geometric modeling and visualization. So-called geometry-oriented approach to the design. So what is geometry-oriented approach to the design? This one, okay? In 3D Max application, even in SketchUp or AutoCAD, all the same way. In terms of geometry, there are vertices and two vertices going to be one single edge, okay, line. And some group of lines going to be face, okay, a face. Faces, so-called polygons, going to be making this kind of product, okay. This is geometric shape of your design, geometry-oriented approach to the design. So in conventional CAD system, such as AutoCAD, SketchUp, even 3D Max, one of our major tools for this semester, is in charge of handling those things, okay? Geometric aspects of design. In the initial stage of computing, people believe that geometric shape is the most important thing for design, new buildings, new products, whatever, okay? So actually, and frankly, geometry is really important, but actually it is just a subset of design, okay? Design has a lot more subcomponents, not only geometry. But anyway, geometry-oriented approach. In terms of geometry-based approach, our major goal is geometric modeling, okay? That is our main subject for this semester. Let's briefly talk about some difference between information handling in terms of architecture, design versus construction. Actually, I roughly showed you this one before, but let's review quickly about this approach, okay? The first thing, as you know, the basic style of architectural drawings invented by Vitruvius, okay, 2,000 years ago. In the Renaissance in Europe, Leon Battista Alberti mentioned and distinguished the architectural design from construction, okay? What did this mean? Before him, before Renaissance, architecture, design, and construction, they always integrated. Simply think about pyramid several thousand years ago. There was no evidence designer for pyramid and constructor for this pyramid, they are different, okay? All the same. So simply around 600 years, that is the period until from Renaissance to until now on, just 600 years have been separated the approach of design versus construction, okay? So he also coined those phrases using some Vitruvius thing. About 100 years ago, the famous phrase for modern architecture, so-called modernism, form follows function, coined by Louis Sullivan, another famous architect. He also referring to Vitruvius. So form follows function means maximize the efficiency of building design. That is why you are nowadays living in this style of building, okay? Rectangle shape, orthogonal walls, no unnecessary decorations, interior, exterior of buildings, okay? Modern buildings, modernism means most of buildings supposed to be box shape, okay? Rectangle shape, because that is the most efficient building, reflecting to its function, okay? So form follows function means function is kind of efficient use of building by occupants. That form is mostly box shape, something like this. How about DDP at Dongdaemun? It's really freeform shape. It's not efficient, but that is totally different shape of design, kind of postmodern, something like that. But anyway, the architectural design, geometric shape, geometric representation is the top priority for design. But for building construction, as well as building maintenance, facility management, geometric shape is also important and critical, but need more information, okay, in terms of building life cycle. But long time in human history, in other words, long time of architecture history, all they are kind of integrated, but separated some 500, 600 years. But, okay, that is why 2D CAD system, AutoCAD, some design tools have focused on 2D geometric shapes, okay, floor plans or line drawings and so on. But actually, some sort of cutting edge technology, so-called BIM, Building Information Modeling, the most advanced CAD system, something different story. BIM aims to integrate entire information set throughout the life cycle of building. That's one difference. But actually, this is out of scope of our class this semester. This is the scope of next semester class, okay? So I would like to introduce you some building object-oriented approach before getting okay. We're gonna have a break, okay? So after the break, we're gonna keep moving on. Okay, let's resume the lecture, okay? So please open the slide. The same slide. Close all unnecessary application, okay? Close web browsers. Please open the slide, exactly same to mine. Okay, let's move on to the lecture slide again. We quickly reviewed geometry-oriented approach to design, okay? But what others? For example, building object-oriented approach to design. In other words, building information-oriented approach to design. Formally, geometry-oriented approach can represent, visualize anything else, okay? Game characters, products, humans, automobile, cell phones, whatever, okay? Using such kind of geometry-oriented approaches. But we are dealing with buildings and buildings subcomponents, building elements, interior facilities, furniture, and so on. So simply recall what you are doing in your design studio work, okay? In your design studio, you are designing some commercial space, for example, how to approach your design. I believe this is very similar to your approach, okay? Let's take a look this representation, building object-oriented approach. Firstly, you have design site, okay, in real world, Hanyang University site or somewhere in Seoul city or different place. There is a site and there is a building or many buildings. For example, this is sort of computer science or engineering notation, which means one site has one or many buildings, okay? That's true. How about this? Building has floors, but one building has one or many floors, okay? There is one-story building or 100 high-rise, 100-story building. So this is the relationship. How about space? One floor has one or many spaces, okay? That is another composition, another relationship. How about space group? In this case, one or many space can have, or vice versa, zero or many space group. How about this space? This is 504 computer lab. But one of the space group named Department of Interior Architecture Design. Our department space has several, our classrooms, offices, labs, and this kind of computer lab, okay? This space is one of our space group named Interior Architecture Department, okay? So this is another type of structure. How about furniture? This kind of desk or this area, instructor's zone, something like that. This is one subset of this space, okay? Interior facilities, subdivided zones, spaces, partitions, they are all one part of space. Space group can be assigned to space, floor, building, whatever, okay? But actually, this is so-called conceptual modeling of a building, okay, in terms of spatial containment, okay? So this is actually conceptual, okay? As I showed you before, design units, two different categories. First one is sort of physical, second one is conceptual. This is conceptual. But Actually, we know this space is kind of physical, but think about it. There is no such physical thing, okay? Space is not visible or not touchable, okay? Simply because this is a void, okay? This is surrounded by 4 walls and ceiling and floor, okay? Not physical. How about floor? Actually, building has a physical object, but one type of conceptual thing, okay? So this is actually something conceptual modeling. But how about this? Foundation, slab, ceiling, roof, beam, column, wall, opening, window, doors. All they are physical design elements of building. And they are so-called structure. One structure has one or many those sub-physical building elements, okay? They are all something about physical components of building, structuring building. So this type of information relationship is one of the simple representation for a building. So this is your approach actually, okay? For visualizing your own specific column, you design some column or walls, windows, doors, floors. And then your structure can be representing your space, your floor, your zone, okay? This is one type of information set, information modeling example, okay? This is building data model, so-called building data model, okay? So think about your SketchUp. SketchUp doesn't have such element. SketchUp has only points, surface, and push and pull, and so on, okay? But you may know Autodesk Revit, which is building information modeling tool. Revit has floor, roof, beam, column, wall, instead of lines, polygons, and so on, okay? Simply because this is building object-oriented approach. But anyway, we're going to deal with the geometry-oriented approach by using 3D Max. So let's briefly talk about this change, okay? This one, now you are second year student, so you may recognize this one is something like floor plan, okay? 4 spaces and 1 single corridor. This is kind of floor plan looking drawing. But in CAD system, AutoCAD or SketchUp, or even in 3D Max, this is office labeled polygon, okay? And series of lines, geometry only. But in object-oriented approach for building design, of course, it's in 3D, and it has amount of information related to this single object named office space, okay? So it has name office, zone name, space number, floor, area, relationship, topological data, as well as 3D geometric data, okay? Geometric data is everything for this kind of CAD system. But advanced smart application in our design computing area for building design, building construction, that is just one subset of entire information set. This is really important difference. But back to reality, back to our class. Why CAD and graphics? Our course title is CAD and Graphics 2. In CAD and Graphics 1 course, last spring semester, you have taught SketchUp and AutoCAD plan drawings intensively in terms of technical training, okay? But based upon that one, now it's time to move on something advanced one, for example, like this one. So at the end of this semester, I like to show you some easy example by using Autodesk Revit application for previewing building information modeling. And next semester, we're going to deal with such part as well as some geometric modeling. But anyway, in reality, in our classroom, our major focus, 2 things. First one is some intensive and theoretical backgrounds in computer graphics and CAD systems, 3D CAD systems. One major application we're going to use in this semester is 3D Max. Okay, we're going to use that from today. And the next one is 3D Max training, as well as some of digital fabrication by using 3D printers or some renderers, Photoshop, design, visualization, representation techniques. Okay, lecture part and lab exercise part. Okay, so two major aspects of design computing for this semester. Simply for enhancing your design visualization skills. Okay, in your design studio work, eventually in the graduation exhibition work, or even realized one when you got a job in design industry, building industry, just we need to enhance your skills for visualization and for moving forward to advanced design computing issues such as BIM. Okay, so lab exercise part, lecture part. Okay, so let's quickly review the history that I showed you before. Simplified history. When we believe that kind of geometric drawing is design, computer tools mostly focus on geometric drafting in 2D. Okay, that looks 3D, but if it's 2D vector graphics, that's just 2D. But some smart people think about we need 3D. Okay, so surface-based 3D modeling tools such as SketchUp, 3D Max, Rhino, invented. Okay, all in 3D. But even smarter people think about surface-based 3D is kind of fake. Okay, our real-world objects are all solid. Inside supposed to be filled with something, not void. Okay, when you game by using your smartphone, tablets, computers, they are all surface-based 3D. That is why you can get into some surface or even some object collision. Okay, but building is solid, so 3D solid modeling invented, and parametric modeling 3D invented, which means parameters to define this geometry. Our building has height with steps. Walls, windows, desk has this kind of parameters. Actually, this is simplified example of parameters. Anyway, they have dimension, not 3D Cartesian coordinate system. Okay, 0.0.0 is my bottom point. No one says like that way in design. Just height with something like that parameters. But cutting edge, so far, the most advanced one is product data modeling or building information modeling that I show you today. Building object-oriented approach to design, simply because we are dealing with buildings. Okay, that is building information modeling. But again, this semester subject is here. Simply let's assume that this is kind of process of your schools, elementary school, middle school, high school, university, graduate school. So where you are in middle school. So even if you got some top level in this course, that's just middle school level. I'm not talking about you are very low qualified or very low things we're gonna learn. My point is we have a bunch of more things based upon 3D visualization by using Rhino, 3D Max, SketchUp, and so on. Okay, there are amount of more issues we can deal with in terms of design and computation. That's my point. Next semester we're gonna cover entire rest of parts. Okay, but anyway, for training based upon this kind of approach and some holistic thinking, in the lab exercise we're gonna mostly focus on this part, 3D visualization. Let's review this design mode again. Why we have to focus on design visualization, design representation. I told you before, in terms of design mode, we have three different types of distinguishing design modes. First one, mode of thought. This is invisible. because it's in your mind. Mode of expression, bring your idea to real world by using hand drawing, but we are using computers. At the end, mode of production. That one should be realized in real world. So mode of thought is plan, abstraction, ideas, concepts, okay? They are invisible. You can express orally. You can talk about your design concept to someone else, but it's not yet visualized. In mode of expression, you can make visual equivalence between your thought and your computational model, your visualization, okay? By exploiting a medium. What is the medium for this semester? Mostly 3D Max, okay? To maximize its meaning. To maximize its meaning means same to visual equivalence between your idea and your visualization, okay? Simply because people only see your visualization, not your thought, okay? No one can see your brain, inside of your brain. Anyway, and then mode of production is next phase, but our class has focused on this mode of expression, mode of visualization. A medium is 3D Max. Kind of difficult. Someone believes it's too hard to learn, but very powerful in 3D modeling and visualization. Of course, there are a bunch of more applications, Rhino, Grasshopper, Maya, even SketchUp. You have very well known to SketchUp or AutoCAD. But anyway, it has its own unique quality. 3D Max, strong point. We have to take maximum advantages from using 3D Max. That's the focus, okay? So I mentioned the term medium. What's the medium conventionally? In terms of human history, from here to this point, human history, 99%, even longer than 99.99% of history, we use this kind of media, hand drawing. But just 0.01% of human history, design history, we used computers, okay? 40 years ago, 3D building model just invented by computers. Just 40 years ago. But human history, longer than 40,000 years, right? So anyway, now we are here for designing by using computers. So we need to know computing a lot more than before. That's my point, okay? Design by pencil to computing. What's the difference? That's what we have to know. We don't need to know to study about pencils, okay? Because pencil is really straightforward, intuitive. Just pencil. But computing technology, no comparison between pencil and computers. This is totally different thing. But you don't know computers. That's problem, okay? We need to know computers somehow in the course. Proliferation of IT, information technology, we can take advantages of such inventions, such advanced devices, machines. That is so-called digital design media, okay? So by using digital design media, here are some examples done by you or your senior students. Even in freshmen, at the first semester of our department students, freshmen, they could do something like this visualization. When you were a freshman, you remember this kind of project, series of projects, okay? Rendered by V-Ray in SketchUp, based upon this kind of computational model, according to the pictures given by me. you are already very well known to this digital design and design visualization, especially using AutoCAD and SketchUp. You are all experts in using AutoCAD and SketchUp, right? And V-Ray, and Photoshop, maybe. In this semester, we're going to use 3D Max design-based class for advanced visualization and representation of your design. That's the topic that I mentioned before, again and again. But overall, we need to know computing technologies, such as very fundamental thing, background thing from computer science or engineering. Such theory gonna make your techniques or your knowledge much stronger. Computer hardware, in 3D Max, even today, we're gonna render something. It takes a really long time. It's very computer resource consuming work. So we need to know something about computer hardware, network, internet. You know how to access local area network, how to use internet, website, cloud computing system. You have to know computer operating systems such as Windows in order to make your work efficient, okay? If you don't know this kind of things, it's not easy to make efficiency or some productivity in your design computing work. Fundamentals of design computing theories, we're going to deal with in my lecture hours, series of rest of lectures. This is main subject, specific application. For example, 3D Max design, mental ray, V-Ray, Photoshop, or animation making, and so on, okay? Even more things about design computing, they are all subject of this course this semester. 3D visualization of design. Actually, this is today's topic, but based upon the lecture and the lab exercise we have been walked through, 3D visualization of design is kind of nowadays really easy and straightforward, intuitive. Let's take a look at this visualization. This one just done by SketchUp and 3D Warehouse and V-Ray in 5 minutes, okay? What you need to do is download this geometric model from Warehouse and put some lights by using V-Ray and render it. So you can generate this kind of rendering in 5 minutes nowadays. 10 years ago, this kind of visualization took more than several hours simply because of computing power or some computing software, lack of computing resources. 20 years ago, this kind of visualization was not possible. 30 years ago, even 2D representation for this one took long time. 4 years ago, first invention of this kind of 3D building. Very fast change. Another SketchUp V-Ray rendering example. In couple of minutes, just 3-5 minutes rendering in SketchUp, okay? Your senior students example. How about this? Today we're gonna make something like this, okay? There is one single plane, another object, torus nut, and cylinder cup-like object. That's it. And mental ray, lighting, and rendering. This one can be generated in 3 minutes from nothing by using 3D Max, okay? So this kind of visualization, representation takes just 3 minutes. That's nowadays technology in terms of computing and computer hardwares. Anyway, today you have to submit something like this, okay? Something like this today by using 3D Max at first use. Also take a look at this one. There is a teapot. This is primitive object defined in 3D Max. 3 cube object and 1 single plane. So total 1, 2, 3, 4, 5 objects as well as 3 lightings. Just 5 minutes needed for making this kind of visualization. Thanks to Mental Ray's Autodesk material, Autodesk wood floor material assigned, chrome metal assigned, ceramic assigned. Just 5 minutes you need for visualizing this kind of thing, okay? This one, another example for submitting today's lab exercise. How about this? This kind of rendering may take very long time in terms of geometric modeling and render time. But anyway, it's nowadays technology to visualize this kind of interior buildings rendering. I showed you last week at the beginning of the course. This is one of the IKEA products brochure, but this is not a picture. They made totally 3D objects and rendering for making their brochure for customers. Their kitchen products, furniture, for selling those products, they just simply create computer-generated images for instead of taking real pictures, okay? For this reason, one of the reasons here, different style of faucets or sinking the washing bowls for different country, they try to make this kind of separate computer tools, not real, simply because it's cost effective, okay? Something like this way. This man in charge of making IKEA brochure in computer rendering by using such applications. We're gonna today we're gonna install this one. Rest of computers in this lab, some of them have it, and mental ray is default renderer, so we're gonna use this one in today's lab exercise hours. At first use, like this guy, okay? So that kind of photorealistic visualization or computer-generated computer rendering is very common and powerful today. Is photorealistic visualization always top priority? What I mean is, should you always make that kind of realistic rendering? My answer is, of course, no, okay? Geometric shape is just one part of the model. Your design should be created by this kind of computational model. For example, 3D Max model, and it's going to be digitally represented for making plans, 3D perspective, elevations, sections, whatever, in PowerPoint or drawing formats, whatever, okay? By using this one source for this kind of multi-use, that's our common process of design visualization. But in terms of this kind of visualization, here is your computational model, which means your mini world, okay, so-called universe of this course. In this universe, actually that is kind of virtual, okay, in your computer application. But in real world, they are supposed to be real object, not yet built, okay, not yet realized. But anyway, they supposed to be same in terms of semantics, okay? That's the major point. Are they semantically same? That's the main question. Even if your mini world is really, really small subset of this real world, anyway, they supposed to be same. Let's take a look at those two different pictures. Of course, this one is looking photorealistic, computer rendered, okay? But this one is very roughly represented. But what if this one has information? What if this one has its radius numbers and its weight, its height, its dimension, its color, or its material? What if this one only has this visualization? If so, this one has more semantic integrity to the real world, okay? This is anyway just one type of representation for your design. Another representation of your design. But according to this picture, we cannot measure the radius, height, its material. We can guess, but not exactly, it's not known anyway. So sometimes photorealistic rendering is very effective and required, but sometimes this kind of just line stroke is enough. In terms of semantic integrity, photorealistic visualization is not always the solution, okay? Architecturally effective visualization is important, okay? Sometimes you draw by lines instead of rendering. That's much effective sometimes, okay? Sometimes, of course, photorealistic rendering is critical. So this is our goal, major goal, design. And there is human's brain area, creativity, okay? This is human creativity area is totally out of computers, computing technologies. In this semester, you will be asked to author, to develop computational model, so-called design authoring, and developing design, visualizing design, analyzing design, all sequential things by using computational processing. That is so-called design process using computers, okay? So at the end, this overall entire process is design computing. But actually, this is computational processing. This part is human brain area. So far, even if there is artificial intelligence, machine learning, deep learning, even if there is Google, human brain area so far kind of isolated from computing. But something overlapped. Think about 100 years from now. I think this area going to be covered lots of human brain area. In that advanced environment, computers, robots can think and create a design. But so far, that's just imagination so far. But we are trying. Anyway, human creativity area and our goal means is computing technology, not just 3D Max, okay? That's important, another issue. So this overlapped part is design cognition, AI, artificial intelligence, machine learning area. In our design computing CAD&graphics2 course, mostly we are focusing on visualization, okay? So let's quickly review 3D visualization, something about 3D visualization by computers. Actually, 3D rendering was you have learned last semester, last year, and most of you are very skillful in rendering, I hope, and I think. Anyway, 3D visualization by computers simply means rendering, but let's take a look at those different pictures. Most of you believes that this is computer rendering. This is not rendering, but that's not true. This is one type of rendering, okay, computer rendering, in line stroke. This is color fill rendering. This is shaded rendering. Another one, texture mapped rendering and ray traced rendering, okay? Some advanced techniques applied for those different renderings. Anyway, they are all rendering. Fundamental rendering things are here. Basics of rendering, 3 points. First one, lighting. Without lighting, nothing visible, okay? Second one, target objects. Third one, your view, your camera. But in general, there is default light, default camera, default view. When you open SketchUp, there is default light, default view. So this is main focus, target object. But you can change lighting source, you can change views. By using 3D Max in today's lab exercise hours, we're gonna deal with anyway those 3 parts. And in the lab exercise for reviewing V-Ray in SketchUp, we're gonna deal with this one again. Target objects, your subject of design. For example, those objects have diffuse reflection, refraction, caustics, And each item has subcomponent like this. That's what we have learned in computer rendering. Again, global illumination, ray tracing, 10, 15 years ago, they are totally new technology, okay? Really hard to do. But nowadays, we can use global illumination, ray tracing as default, okay? In 3D Max, default renderer mental ray has default GI and ray tracing. Left one looks like photorealistic, but not true. Simply because, take a look. This one, this wall has green color, but it's not global illumination based rendering. That is why no green color except this reflection. But this is real. White color walls affected by green color here, and this lighting has been penetrating this one, and caustics, okay? Another lighting source for this one from this lighting. Caustics, ray traced, okay? So this is sort of default in nowadays computer visualization tools, including 3D Max, mental ray. So very powerful, very useful. What you need to know is not simply how to use such application, okay? We need to figure out behind the technologies and mechanisms. That's my point. And here I list up rendering overview, 3 major points: lighting, object, view, camera, okay? In subcomponents, all they have color, intensity, texture map, transparency, glossiness, and so on for the object. For the lighting, we have some keywords for camera, views, and so on. We're gonna walk through again by using mental ray or even V-ray in 3D Max, as well as very complicated and time-consuming geometric modeling. We're gonna deal with visualization rendering features first, and then move to geometric modeling by using 3D Max, okay? That's what we have to do for this semester in the CAD&graphics2 class. Have a question? Okay, let's finish the lecture and have a break. Just wait a second, okay? Let me finish the lecture and I'll let you know some technical note for lab exercises and some software installation.